Hi, so now that we have a little more complicated example for increasing annuities and perpetuities. So this example, the payment increases at first, then level. So consider the time diagram. One to infinity. And the payment amount is $1 times 1, $2 times 2, and the $10 times 10. So it's increasing over time. Then $10 a year forever. And suppose that annual interest rate is 4% effectively. So what is the present value of this annuity? So it's a mixture of the constant perpetuities and the increasing annuities. And to calculate present value, again, we have to divide this cash flow into two pieces. So the first piece is the first 10 payments. So this is an increasing annuity for 10 years. And the second series of payments is this $10 forever, starting at t is equal to 11. So we want to calculate the present value of each, then finally the add up. So present value of cash flow 1. So this is annuity for 10 years, increasing annuity for 10 years. So IA, right angle 10 at 4%. Or you can say in the corollary, the P is equal to 1 and Q is equal to 1. So in any case, so this is equal to the 1 plus I, so 1.04 times A right angle N, so A right angle 10 at 4% minus 10 times V to the power N, so 1.04 times power negative 10 over 0.4. And A right angle 10 is obtained by the calculator, and this becomes 41.992. So this is the present value of the first series of payments. So what's the summation of these numbers? 1 to 10, the sum of 1 to 10 is 55. So we have about $13 discount because of 4% interest. So we have the 10 payments. So yeah, it's hard to say, but so the amount is in account for 1 to 10 years. So, and the interest is 4% per year. So roughly speaking, we have maybe the 20% of interest, because 5 years times 4%, or maybe 6 or 7 years. So the little more than 20%, 20% of interest that it earns. So present value has the discount of that amount. So it sounds reasonable that we have about $42. And how about the present value of the cash flow 2? Present value of the cash flow 2 is basically the annuity due or annuity immediate, the perpetuity immediate or perpetuity due, but the start at 11. So we regard this as the perpetuity due, perpetuity immediate of $10 each. So this is the V to the power 10. So basically we evaluate the cash flow Y at time 10. Then this is the perpetuity immediate. So this is the V to the power 10 times Y. So this is the V to the power 10 times Y. Y is equal to 10 times A right angle infinity because this is annuity, the perpetuity immediate. So this is what? This is the v to the power 10. So the v is 1.04 to the power -1. So the 1.04 to the power -10 times 10 times the a right angle infinity. But the a right angle infinity is 1 over I, so 1 over 0.04. That is 25. And finally, we can calculate it. This is 0.67556 times 10 times 25. And this becomes $168.89. So the sum of these two quantities should be the present value of this increasing and then level annuity. So PB is equal to PB of 1 plus PB of 2. So this is the 41.99 plus 168.89. So this is equal to $210.88. Yeah, so for this kind of the complicated annuity, we can divide this into two parts. One is increasing annuity part, and the second part is the level perpetuity. So we may have some different strategies, but this is one of the simplest solution to answer this question.